Okay, kids, spring break, yay! And I gotta do homework. Oh no, maybe get it done early. That's why I'm trying to get this done. But don't forget when you come back, there will be a quiz. Maybe I'll put some hinters over vacation. Hinters? Is that even English? I don't even know. Welcome to Mr. Krause Math. We're gonna talk about the Pascal's triangle and something called binomial expansion. Man, whew! It doesn't get any more exciting than that, dude. All right, I'll stop talking like a moron, and you start listening. Let's take out blue. All right, so anything, and I mean anything, raised to the 0 power is equal to 1. I'm going to put it in the middle. You'll see why later. X plus y to the first power is just 1x plus 1y. You'll see why I'm doing this in a minute. It's kind of cool. Make sure your notes follow my notes. Ooh. 7 o'clock at night. So now this one, I'm drinking coffee, we have to write as x plus y times, x plus, I'm having a hard time writing today. I don't even know what's wrong with me. This is x squared plus 2xy plus y squared. So that's 1x plus 2xy plus, this is squared, plus 1y squared. Moving down. Now we're going to do cubed. So now we got to do it 3 times. I'm going to just use one of these. X plus y, x plus y. Well, I've already done 2. It's just that. So really what I have here is x squared plus 2xy plus y squared times x plus y. And then this would give me, I'll do purple, x cubed plus x squared y plus 2x squared y plus 2xy squared plus, I'm going to do it in alphabetical order, xy squared plus y cubed. Now when I clean all this up, I get x cubed plus 3x squared y plus 3xy squared plus y cubed. So let's go back up here. I don't like where I put this one. So this one became 1x plus 2xy plus 1y squared. And this one became 1x cubed plus 2x squared, not 2, 3. 3x squared y plus 3xy squared plus y, or 1y cubed. That was that one. Now we got one more to do. We got 4 of them. Well, 4 of them is x cubed times x plus y, which is really just this times x plus y. So we're going to take x cubed plus 3x squared plus y plus 3xy squared plus y cubed, and we're going to multiply by x plus y. And we'll see if we can do this in a relatively neat and orderly fashion. I'll do it in red. So I get x to the 4th, and then x cubed y, and then plus 3x cubed y plus 3x squared y squared plus 3x squared y squared plus 3xy cubed plus xy cubed plus y to the fourth. Holy mackerel. So this is going to give me x to the fourth. These two give me plus 4x cubed y plus, and then these two, nope, these two give me 6x squared y squared plus these two give me 4x y cubed plus y to the fourth. Wow. So this thing became 1x to the fourth plus 4x cubed y plus 6x squared y squared plus 3xy cubed plus, it should have been 4. Why do I keep putting 3 there? I don't know. I'm doing crazy. 4xy cubed plus 1y to the fourth. Well, I hope you notice the patterns in exponents. You'll notice that the x is going from squared to 1 to none, and the y is going from none to 1 to 2. Or if I look at it here, my x cubed, x squared, x, no y, 1y, y squared, y cubed, or x to the fourth, x cubed, x squared, 1x, and no x. And then no y, y to the 1, y squared, y cubed, y to the fourth. So, what's the pattern? The first value, x, is going down, while the y value is going up. Now I say x and y, this is really the first variable. His exponent goes down, and this is the second variable. Well, you can imagine how difficult this would be if my next thing I asked you to do, I said, okay, let me put this in black. If I said, okay, I want you to do x plus y to the 10th. And then, heaven forbid, I ask you to do 2x minus 3y to the 10th. You'd be like, what? Do you know how long that would take? That would take forever. Well, there's a couple of different ways to handle this. We have this thing called Pascal's triangle. Let me try to explain Pascal's triangle. What it does is it works with the coefficients. So what do you notice about this, 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 and this at the beginning and at the end? You notice those are all ones, right? Well, I'm going to start working on the pattern. I'm going to wonder if you can kind of figure out how it works, how it goes. So, 1, 1, 1, right? This was just 1. This was, and then this was 1. I'm going way too big. Sorry about that. 1, 1, 1, 1, 2, 1. Switch colors every time. 1, 3, 3, 1. Anybody see the pattern yet? 1, 4, 6, 4, 1. Pascal's triangle. I personally don't like this. I don't like using this because this takes forever to draw out this. 1, 5, 10, 10, 5, 1. One. Anybody want to guess? Want to guess? Let's see if you're right. Guess. 6. If you were right there, do you know this one? 15. 20, 15, 6, and 1. Now, how am I getting that? Well, let me grab purple. I'm getting it by taking these two and adding them up. Taking these two and adding them up. Any two on the previous one, this one and this one add up to 10. This one and this one add up to 10. This one and this one add up to 5. Now, these two add up to 6. These two add up to 15. These two add up to 20. These two add up to 15, and so on. So you should be able to tell me what this next one is going to be before I grab my red pen and do it. I'm going to start with 1, and we're going to end with 1. Now see if you can take a second to write that in. So, these two give me 7. These two give me 21, 35, 35, 21, and 7. So, what kind of patterns do you notice? What kind of patterns do you notice? Well, some of the things that you're probably noticing are that these are all 1s, and these are all 1s. What do you notice about the next row? Let's take, or the next kind of row here. Take a look at these. The next group is just 1, 2, 3, 4, 5, 6, 7. What do you notice here? Add 2, add 3, add 4, add 5, add 6. What's this one? Add 3, add 6, add 10, add 15. That's kind of a weird one. There are lots of different patterns, and you can study this someday and talk about Pascal's triangle and how all this stuff works. Well, there's lots of different patterns that you can see. The big thing is, I want you to remember is that it's the sum of the two previous. So how is that going to help us out? Well, this line here represents, if I had something like x plus y to the 6th, I would use this row. 1, that's 0, 1, 2, 3, 4, 5, 6. So that would be the 6th row. And I would use those coefficients. Notice there's 1, 2, 3, 4, 5, 6, 7. Now, why is that? Well, you need an x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, and x to the 0, which is really just a constant. Really no x at all. It's just a constant. Those of you that were working with me on the last spiral, and I said, why don't you use menu 331 to check that answer, you always ask, why was there an extra box? So let's get started on how we're going to use this to solve this problem. Well, I'm going to start by using Pascal's triangle. Again, I don't like Pascal's triangle, but I can see how some of you might. So the first thing I need to do is come up with the 4th row of coefficients. So 1, that's the 0 row, 2, 1, 2, 3, 4. This is going to be the row I need. Now I can go back to the other page and look, but I want to get it now. Again, 1, 1, 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1. So these are the coefficients that I need for my polynomial. Expand the binomial using Pascal to find the coefficients. So these are the coefficients we're going to use. So how does that work? Well, here's how it works. This is my first term. So I'm going to go 1, I'm going to write this out. 1, 4, 6, 4, 1. And after each one of these, I'm going to put 2 sets of parentheses. You'll see why in a second. And it goes back to some of the stuff we did back up here when you're looking at the exponents that I was talking about. So what we're going to do is we're going to take this first exponent. First thing, it's an x. Well, the highest exponent is a fourth degree polynomial. So this is going to be to the fourth. This is going to be cubed. This is going to be squared. This is going to be to the first. And this one's to the 0. And probably what I should have done, I apologize, I should have probably put these numbers in a different color. So let me do that. 4, 6, 4, and 1. So what I did was I went through and I put those exponents. Now these exponents would go 0, 1, 2, 3, 4. In much the same way up here, if you look up here, x to the fourth, cubed, squared, 1, and nothing. This was nothing, 1, 2, 3, 4. We're just putting those exponents in. Now comes the magic. Now you're just going to put the variables in. So in the first one goes x. X goes for the first one because that's the first thing in the binomial, x and x. And in the second thing, we're going to put negative 3. Negative 3. Negative 3. Negative 3. Cram that baby in there. Negative 3. Okay, we're almost done. X to the 0, or negative 3 to the 0 is just 1, and x to the 0 is just 1. So I really don't need those two, but they're kind of placeholders. So this gives me x to the fourth. Now, this is going to be 4 times negative 3, so that's minus 12 x cubed. And then this is going to give me 6 times, well, what's negative 3 squared? Negative 3 squared is 9. 9 times 6 is 54. So 54x squared. And then 4 times, well, negative 3 cubed, this right here, negative 3 cubed is negative 27. And negative 27 times 4 is negative 108. X to the first. I can put the 1 there. I don't really need it. And then I've got negative 3 cubed, which is positive 81. And that is this binomial. Now, I could have gone through and double, quadruple, distributed it, but it gets harder and harder and harder. So now this one's to the 5th power. So let's get one more row on here. 1, 5, 10, 10, 5, 1. Now, 1, 2, 3, 4, 5, 6. We need 6 items. So I'm going to come through and put those coefficients in black. And those coefficients were 1. Forgot them already. I think it was 6, right? No, 1, 5. Obviously, it's 5. 1, 5, 10, 10, 5, and 1. Barely fitting that in there. Then I'm going to come through and do my parentheses. Now, I don't know what sign goes in between. I mean, you can put a plus in here. It doesn't really matter. Eventually, we're going to figure out if it's a positive or negative. So, all right. So, in the first one, in the first set of parentheses, goes x. Oh, wait, I'm going to do the exponents first. So, we're going to start at 5. 5. 4, 3, 2, 1, 0. Start at 0, 0, 1, 2, 3, 4, and 5. Now I'll go through and put the x's in. X, 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 and X. Well, I bet that was behind my head. And this should look better here anyway. All right. Now in the second set, I'm going to put in. In the second set, I'm going to put in these 3s. So 3, 3, 3, 3, 3, and 3. So we're going to combine. Now, remember, the zeros is really just a 1. So that's really just a 1, and that's really just a 1. I don't need it. And this is just 1x to the 5th, or x to the 5th. This is 5 times 3, which is positive 15x to the 4th. This is 10 times 3 squared. 3 squared is 9, so that's plus 90x cubed. This is 10 times 3 cubed. 3 cubed is 27, so that's 270x squared. 5 times 3 to the 4th. 3 to the 4th is 81. 5 times 81 is 405. 405x. And then 3 to the 5th is 81 times 3, which is 243. So plus 243. There is the binomial expansion of that. All right, so let's try another one. 4. So if I go back to my thing, 4 was 14641. You're going to start to memorize these one. So put them at 1, 4, 6, 4, 1. And I'll put pluses in front. It really doesn't matter for now. It may be negatives, it may be positives. Since these are both positive, it'll all be positive anyway. Let me get my parentheses. 1, 2. 1, 2. Parentheses help, especially when you're dealing with negatives. You should always sub in using parentheses. Now we're going to do the exponents, so I'll do those in red. So we're going to start at 4 and go down. 4, 3, 2, 1, goose egg. And if you want at that time, you can just get rid of that. Goose egg doesn't need it. And start at 0. Oh, we don't need that one. 1, 2, 3, 4. All right, in the first one is going to go the A's. A, and A, but I'll need it. And the second one's going to go 2B, or not 2B, 2B, 2B. We got to be careful with this one, 2B. So that goes away. This is just A to the 4th plus. Now it's going to be 4 times 2 to the 1st. 2 to the 1st is just 2, so that's 8. A cubed B. Notice now this had no B's. Now we have 1 B. This had 4 A's. Now we have 3 A's. Notice the A's are going to go down and the B's are going to go up. So plus 6 times, be careful, it's not 6 times 2, it's 2 squared. 2 squared is 4. 6 times 4 is 24. A squared, B squared. Notice A went down, B went up. Plus 4 times 2 cubed. 2 cubed is 8. 4 times 8 is 32. A to the 1st, B cubed, because it's B cubed, right? Notice the B's going up and the A's going down. And the last one is finally just 2 to the 4th, which is 16, B to the 4th. All right, so this one's a little bit tricky. Not a little bit trickier. It's not bad. So we got to go to the 3 one, and that's 1, 3, 3, 1. So the coefficients here are going to be 1 plus 3 plus 3 plus 1. And I get my parentheses in there. Take out my red pen, put the exponents in. We're going to start at 3. 3, 2, 1, 0. You know you screwed up if you're out of things and you got to go to negatives, because you ain't going to negatives. We'll start at 0, get rid of that one. We don't need it. 0, 1, 2, 3. So in this first one, we will put whatever's first. 5. Okay, 5. 5. 5. And 5, but we don't need that one. And then the second one, we're going to put negative 2y. Negative 2y, but I don't need it. Negative 2y. You got to be careful with the negative. Negative 2y. Be careful with the negative. Negative 2y. All right. Let's see what we got here. 5 cubed. 5 cubed is 125 plus 3 times 5 squared times negative 2. We got lots of numbers here, kids. So 3 times 5 is 15 times negative 2 is negative 30. So you got to be careful with your signs. Negative 30y. Notice the y's are going to go up. Y squared, then y cubed. So now I'm not even going to put a sign. 3 times 5 is 15. And this is negative 2 squared. Negative 2 squared is 4. So 15 times 4 is positive 60 y squared. And finally, negative 2 cubed. Negative 2 cubed is negative 8 y cubed. There it is. All right. So, you know, Pascal's triangle's nice. But if I asked you, if your problem was, let's say your problem was this one right here. And I had to go to the 10th. So you'd have to go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And I'm only halfway there. I mean, you're going to be, you know, that last row is going to be down here and it's going to have 11 things in it. It's just too much. It's just too crazy. So what I want you to see, and the way I prefer that you do these is this. We're going to do it slightly different. We're going to use this thing called combinations. Now this is on your formula sheets. And when you look at it, you're like, what in the heck is that thing? That's crazy. I should have my calculator up. Oops, sorry about that. I should have my calculator up. I don't actually need these. So let me get my calculator up. Let's go back. I don't need these. And we're going to OneNote. Okay. So where do these numbers come from? Let me go back to Pascal's triangle. I'm gonna put this as neat. You don't need to do this up here, but I'm gonna go back and make this all kind of neat. So let me get to the 4th row. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. That's the 4th row, I guess. So in here, the exponent then is cubed, right? Because it's of whatever that is. Where's my calculator? So how do I get those generators? Or how can I generate those numbers without having to do that entire thing? Well, I can use what this thing is, combinations. The formula uses something called combinations, which is probably something you may or may not learn now in 9th grade, but we're going to use these things called combinations. And this is the most important thing right here. NC1, NC0. So, here's how we do it. Where am I going? We're going to use this thing called combinations or combinatorics. And we're going to do a little bit more with this when we start talking about probability. So I want to generate this row. So what we're going to do is we're going to say, okay, sorry, I thought I got rid of that. Okay, so we're gone. So let me get my calculator back. So anyway, what we're going to do is we're going to generate that. And we're going to use this thing called combinations. Combinations. How many different ways can I choose 3 things? Since the exponent in this column, the exponent of this row is cubic, it's something cubed. We're going to use combinations to figure out how to do it. So this first one is, how many times can I take 3 things and choose 0 of them? How many of these can I take 3 things and choose 1? How many days can I take 3 things and choose 2? How many different ways can I take 3 things and choose 3? And if you don't remember that, that's okay. But we'll go into menu, probability, and we're going to combinations. And just the way it is, and this first one is 3, what is it? Where's my comma? Forgot where the comma is. 3, comma, 0. 3 things, we want to take none of them. How many different ways are there 3 things and you can take none of them? Well, there's one way. Then I want to do 3 things taking 1 of them. Then I want to take 3 things, and you'll get good at this, taking 2 of them. And then I want to do 3 things, taking 3 of them. 1, 3, 3, 1. There it is. So let's say I wanted the 8th row. I want whatever it is to the 8th row. So, I don't know. Now, here's the thing. It's going to begin with 1. It's going to end with 1. This is going to be 8. And this is going to be 8. And there should be 9 things. Remember, it's always one more. See how there's 4 here? It's always going to be one more than the number you have. So, I mean, I could do this. Oops, sorry. Let me clear that out so you don't have to see that anymore. So we'll go menu, probability, and you can do combinations on almost any calculator. 8, comma, 0. Enter. 1. 8, comma, 1. 8. I want you to start to recognize some things. We're going to start to recognize more patterns. That's why I got that patterns box up there. 8 choose 2 is 28. Now we're going to do 8 choose 3. 56. Now we're going to choose 8 choose 4. You're going to start recognizing some patterns soon so that we don't have to do this all day. 70. 8 choose 5. 5. 56. That's weird. 8 choose 6. Oh, 28. That's weird. 8 choose 7. And there's 8, and the last one's 1. So if you notice, what do you notice? Do you see any symmetry here? Like this starts with 8 here. 28, 56, 70, 56, 28, and the next one's 8, and the next one's 1. So 8, 28, 56, 28, 56, 28, 8, and 1. That's 1, 2, 3, 4, 5, 6, 7. Oh, man, I don't have enough items. What happened? I missed a few. Go back to my calculator. Oh, 56. Wasn't following my pattern. 8, 28, 56, 70, 56, 28, 8, and 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. I got it. So let's say I wanted my 10th row. So I know it's going to be 1 and 10. I know it's going to end with 10 and 1. And I really only got to get to the middle, and then the pattern repeats itself. So I'll go, let me clear this out. And I'll go menu, probability, combinations. And I'm going to do 10. I don't need to do 10C1. I don't need to do 10C2. Or I don't need to do 10 and then comma. So I want to do 10 comma 3. And that's 120. So remember that if this is to the 10th power, I'm going to have 11 things. 1, 2, 3, 4, 5, 6 is when I'll stop. And it should start repeating its pattern. But maybe I'll check that just real quick to make sure I don't screw that up. So enter, who knows, delete 4, 210. And then, do a couple now, 5 and 6. Let's do 5 and 6. 5. and then 6. So 210, 252, 210 again. 210, 252, 210. Did I miss one? I feel like I missed one. 3, 4. Oh, I missed 2. Doggone it. I knew I missed one. So it should go 1, 10. I missed 2, like a dummy. I don't know why I went to 3. 10, 2. Okay, 45. Okay, so it should go 110, 45, 120, 210, 252. And notice now it's going to start repeating itself again. So 210, 120, 45, 10, and 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you only ever have to get halfway and it repeats itself. You know, we can come back down here and take a look. Look at here. 1, 5, 10, 10, 5, 1. Now, so this was to x to the 5th, right? So with the odd ones, since you're going to have 6 things, you know, the middle will be 3, they'll repeat. But in the even ones, the middle one will be a different number, and then we'll go down and up, right? So 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So the patterns repeat themselves. So let's go down here, and let's see how that's going to help us out. I want the pattern for this. Well, I know it's going to be 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, and 4, choose 4. Furthermore, I know what those numbers are, most of those numbers. I know that always starts with 1, ends with 1. The next one's going to be whatever the exponent is, 4 and 4. So really, this is the only one I need to know. I don't need to write that whole thing out for this one problem. I just got to figure out what 4C2 is. So I come over here, I hit the up arrow, menu, probability, combinations, 4, comma, 2, enter, 6. Oh, it's 6. Okay. So, and I'm not even going to write all this out yet. I'm going to put the numbers here. I'm going to put my parentheses here. I won't write it all out. I'll show you in a second what I want. So we're going to do it this way from now on. Then we're going to come back up here. Let me grab my red pen. And we're going to go 4, 3, 2, 1, 0. We don't need 0. 0, 1, 2, 3, 4. In that first set of parentheses, we're going to put whatever's first. Whatever's first in this case is 4. 4, 4, 4, and 4. In the second set, we're going to put the y. Y, 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 and y. And we're going to find out what these things are equal to. So, 4 to the 4th. 4 times 4 is 16, times 4 is 64, times 4 is 258. So this is 258. 4 times 4 cubed, well, 4 cubed is 64, times 4 is 258. Why? Oops, I forgot the 8. 258. Why? All right, 16 times 6. 10, 6 times 10, 60. So this is 96 y squared. I'm just multiplying all the numbers together. 4 times 4 is 16 y cubed. Notice the y's are going up. And then this is just 1 times y to the 4th, y to the 4th. So my final answer is, and I would like this in standard form, which means the highest exponent comes first, y to the 4th plus 16y cubed plus 96y squared plus 258y plus 258. All right, moving on. 5th. So, let me grab my black pen. I'm going to go down here and I'm going to say, okay, it's 5C0, 5C1, 5C2, 5C3. And if you've forgotten what the C's stand for, we're going to get into that when we get into probability. 5C5. Basically what it says is if you have 5 things, how many different ways can you take 0? How many different ways can you take 1? How many different ways can you take 2? And so on and so forth. This is 1. This is 1. This is 5. and this is 5. So I've got 2 left here. Well, they're going to be the same. I just don't know. I just don't remember what they are. So I'll say, okay, menu, probability, combinations, 5, comma, 2, boom, 10. Oh, yeah, that's right. They're 10. They're both 10s. So I'll do my parentheses afterwards. These are kind of time-consuming problems because you got to write stuff out. And I get to do my exponents. Start with 5. 5, 4, 4, 3, 2, 1, 0. Don't need it. 0. Don't need it. 1, 2, 3, 4, 5. Remember, anything to the 0 power is 1. So you're really just multiplying by 1 there. So it really doesn't matter. All right. X goes in the first one. Sorry, this one's right here. And this is going to be tough, negative 2y. Because this is a negative, every other one is going to be negative, and every other one is going to be positive. You'll see why in a second. So if you get stuck, you can just type this in your calculator. But this first one's really easy. This is just x to the 5th. So this is 5x to the 4th, negative 2 times negative 2. So we're going to, really what you're going to do is you're going to grab your calculator and go, okay, 5 times negative 2. Boom. Negative 10. Okay, so this is equal to negative 10 x to the 4th y. Notice the x's are going down. The y's are going to go up. Grab this one. 10x cubed negative 2 squared. So you can just do that in your calculator. So you can go, I forgot what it was. 10 times negative 2 squared is 40, so positive 40, x cubed y squared. And notice the exponents always have to add up to 5. They always have to add up to 5. They have to add up to whatever this is. So now we're going to do 10 times negative 2 cubed is negative 8. So this would be negative 80 x squared y cubed. Notice the exponents add up to 5 again. Negative 2 to the 4th is 16. 16 times 5 is 80. So this will be positive 80x y to the 4th. And the final one is negative 2 to the 5th, which is negative 32 y to the 5th. All right, let's put our final answer out here then. We'll get it a different color. So our final answer is x to the 5th minus 10x to the 4th y plus, notice how every other one's going plus and minus 40, x cubed y squared minus 80 x squared y cubed plus 80 x y to the 4th minus 32 y to the 5th. Now notice exponents add up to 5, 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 and so on and so forth. All right. B to the 4th. We just did that one. So 4C0, 4C1, 4C2, 4C3, and 4C4. And we really already did these, so we already know this is 1, this is 1, this is 4, and this is 4. And if you look back, this is 6. 2 sets of parentheses. Take out my red pen for my exponents. 4, 3, 2, 1, 0. Don't need it. 0. Don't need it. 1, 2, 3, 4. First one goes up or down. The second one goes up. Now, if you ever screw that up and do it backwards, it's not a big deal. Oh, lost the light. How did I do that? How did I lose that light? Let me pause for a second. Sorry. Oops. Sorry about that. Lost a few little lights there, so probably saw my green screen. So on this first one, we're going to put 2a, 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 2a. and 2a, but we don't need it. And the second one, we're going to put b. b, 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 and b. So this one's going to be 1 times 2 to the 4th. Now, 2 to the 4th is 16. So that's 16a to the 4th. Everything's positive, so we don't have to worry about that. 2 cubed is 8. 8 times 4 is 32. A cubed, A is going down, B is going up. We now see B. 6 times 2 squared. 2 squared is 4, so this becomes 24. A squared, B squared. B is going up, A is going down. This is going to be equal 4 times 2 is 6. A, B cubed. And finally, this is just B to the 4th. So we'll write our final answer here. 16, A to the 4th, plus 32A cubed B, plus 24A squared B squared, plus, oh, you can see this with all my big head in the way, plus 6AB cubed plus B to the 4th. All right, so that's not so bad so far. Okay, what would you do if you got to this problem? You'd have to create 7 rows of that Pascal's triangle and hope you didn't make a mistake and hope you got the right numbers and hope you did the right arithmetic. Man, that's a pain in the neck. So we're not going to do it that way. We're going to go 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, and 7C7. Now, 1, 2, 3, 4. 1, 2, 3, 4. So that's halfway. Once I get to halfway, remember, this pattern is going to repeat itself. I know this is 1. I know this is 1. I know this is 7. And I know this is 7. The other ones I don't know. So the other ones I don't know. I hate to always think, okay. So the other ones I don't know. So what I'm going to do is menu, probability, combinations. 7, comma 2. I don't know 7, comma 2. It's 21. Hate that. 7, comma 2 is 21. So if that's 21, this one's 21. So I only got one more to go. 7, comma 3. And that's 35, so if that's 35, that one's 35. So I'll put some parentheses afterwards. I hope I don't have too many. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's a great test right here. You'll see where we're getting a good test. 7, 6, 5, 4, 3, 2, 1, 0. We don't need it. 0. We don't need it. 1, 2, 3, 4, 5, 6, 7. Yes, this is time consuming no matter which way you do it. So let's get the cool blue pen out then. K goes here. K for Kraus. K, 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 K. And then -3. That's the thing that's going to be tricky. That -3 is going to be tricky. Be careful with your negatives. Smart kids really just type this stuff in. Well, really smart kids do it in their head. Smart kids type it in. Dumb kids just, I don't know. I don't have any dumb kids. I don't have to worry about that. So 1 times K to the 7 is just K to the 7. 7 times -3 is -21 K to the 6th. 3 squared is 9. 9 times 21 is 189 K to the 5th. Now it's going to start getting crazy. So now I'm going to grab my calculator. 35 times -3 cubed. So 35 times, use parentheses, -3 cubed. -945. That's right, kids. -945 K to the 4th. Now we're going to do 35. So basically it's going to be that exact same thing, but in this case it's to the fourth power. This one's going to be positive 2835. So 2835k cubed. Now it's 21 times negative 3 to the fifth. 21, parenthesis, negative 3 raised to the fifth power. Negative 5,103. So negative 5,103k squared. Now 7 times negative 3 to the sixth. So 7, negative 3. So I'm just using my calculator. I don't know all this stuff. Negative 3 to the sixth. Oh, 5103, but this case positive. K. And finally, negative 3 to the seventh. Use parentheses, otherwise you're wrong. Let me show you what happens when you don't use parentheses. Well, in this case, it wouldn't make a difference. Negative 2187. So negative 2187. So writing this baby out in all of its glory, it's k to the seventh minus 21k to the sixth plus 189k to the fifth minus 945k to the fourth plus 2835k cubed minus 5103k squared plus 5103k minus 2187. Wow. Wow. That's a seventh degree polynomial. So here's what generally gets asked. It says we have a fifth degree, but I only want the third term. So I don't have to do this whole thing. I don't have to come up with all of this. It's crazy. That's a lot of stuff. I only want the third term in the expansion series. So here's how this works. Third term, 1, 2, 3. We want this term right here. Okay? So we're going to do it. 5C0, 5C1, 5C2. We're going to stop. This is 1. This is 5. And if you did 5C2 on your calculator, you'd get 10. This is the only one I care about, but I'm going to put these parentheses because you'll see why in a minute, just to help me with the exponents. And this exponent starts 5, 4, 3. Remember, this is the one I want. 0, don't need it. 1, 2. So I don't care about any of this stuff. All I care about is this one right here. So that's the only one I'm going to work with. Oops. So in this one goes the 4, and in this one goes the x. So this is 10 times 4 cubed. 4 cubed is 64. 64 times 10 is 640 x squared. Done. All right, we want to do the same thing in here. I want the third term in this expansion. So I want the 1, 2, 3 term. This is the term I want. 4C0, 4C1, 4C2. Now, if you don't remember what 4C2 is, I don't even care what these are. I care what this is and some parentheses. Phone's going off. Hope it's not important. Doesn't look like it. All right, well, anyway, let me get my thing. This is going to go 4, 3, 2, 0. Don't need it. 1, 2. So I don't care about these. And if I did 4C2 on my calculator, I'd get 6. I'm going to put 3x here and negative 2y here. Now, this is kind of crazy. So what you want to do is you want to go through and you want to put in all the stuff that's numbered using parentheses and everything else. Oops. So it was 6 parentheses. Don't remember. 3x. I don't care about the x. I just care about the 3. 3 squared. Parentheses. Negative 2 squared. There it is, all of it. I just take in and put all the numbers, and that's going to give me the number 216. X squared, y squared. There's my answer. Wow, wow, wow. I want the x to the fifth term. That one's kind of tricky. X to the 5th. So let's see how that's going to work. So I got to get, let's see what I got here. When I had the third term, it only gave me a squared. So maybe I need to go one more than 5. So maybe I need to go to the 6th term. 1, 2, 3, 4, 5, 6. I'm thinking I need to go here. So let's see what we got. 10C1, 10C2, 10C3, 10C4, 10C5, 10C6. I'm not sure if I'm right. Maybe I am, maybe I'm not. I don't even know. We'll see in a second. Now, I'm not going to figure out what all that stuff is because I don't really care. I think it's this one, but I need my parentheses to figure out. You'll see why in a second. I just need my parentheses. They help me with my exponents. And I don't need to go past this. I don't need to go all the way down, keep going. I just need to stop there. So let's see. 10, 9, 8, 7, 6. Wait, hold on. 1, 2, 3, 4, 5. I missed one. Shoot. I always do that. Sorry, I lost track. Okay, so we need one more set of parentheses, 5 here. So this is, in fact, the one I want. This is, in fact, the one I want because, remember, in this first set of parentheses, so hold on, this goes 0, don't need it, 1, 2, 3, 4, 5. So remember, in this first set's going to go x, and the second one's going to go -2. So this is my x to the 5th. So I need to figure out what 10C6 is. So menu, probability, combinations, 10, 6. Oh, it's 210. X, -2 to the 5th. All right, so I'm going to type in all the numbers, 210 and -2 to the 5th. So 210, parenthesis, -2 raised to the 5th. -6,720, -6,720 x to the 5th. Am I done? Oh, find the coefficient. Oh, the only thing I want is -6,720. There it is. All right, I think we got 3 left. Find the middle term. All right, I don't know what that is. 6C0, 6C1, 6C2, 6C3, 6C4, 6C5, 6C6. I think this one's in the middle. All right, that's the one we need. So I'll come by, I'll put my parentheses afterwards. Now, I need all the ones above it just to help with the exponents. So I need all of these above this just to help with the exponents. So 6, 5, 4, 3. And if I remember, they have to add up to 6. This is 3 here, but 0, don't need it. 1, 2, 3. So this is the one I need. I need to figure out what 6C3 is. So menu, 5, 3, 6, 3, 20. So this is 20. In the first one goes x. In the second one goes 3. So I'm going to type in, well, 20 cubed, 3 cubed is 27. 27 times 20 is 540 x cubed. There it is. Find the 5th term. Now, I only want the coefficient of the 5th term, but this is going to be kind of tricky because I got fractions. Ooh, fractions. So 5th term, 1, 2, 3, 4, 5. I need this term. 7C0, 7C1, 7C2, 7C3, 7C4. This is the one I want. I'm stopping here. I need parentheses to help with the exponents. And I really only need these. And I'll tell you why in a second, and maybe you can figure this out. Let me get black. 7, 6, 5, 4, 3. Well, the exponents have to add up to whatever this is up here. They have to add up to 7, so this has to be a 4. Now, if you don't like that, if you don't recognize it, you can still do this. 0, don't need it. 1, 2, 3. Oh, yeah, it's 4. So come back over here. We've got 2 problems left, kids. 2/3 x goes here, and -1 goes here. Now, I don't know what 7C4 is, but we got to figure out what that is first. So, menu 5, 3, 7, comma, was it 3? I don't think it was 3. It wasn't 7, comma 4. Shoot. 7, comma 4. 7, comma 4 is 35. So what I'm going to do is type in all of this crap. 35, 2/3 cubed, -1 to the 4th. So 35, parentheses, control division, 2/3 cubed. Now, I'm going to do -1 to the 4th. In reality, I would never do this because -1 to the 4th is just 1. But because you guys may not believe me, I'm going to put all of it in. Just put all the numbers in. Oh, 280 over 27. No problem. 280 over 27 x to the 3rd. That's it. Done. Last problem, kids. Oh, my goodness. This one looks hard. Find the middle term. Now, you can only find middle terms of even ones. So 4C0, 4C1, 4C2, 4C3, and 4C4. This is the one I want. I don't care about these. This one's the one in the middle. Parentheses, 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 parentheses. 4, 3, 2. Oh, that's 2. This has to be 2. 0, 1, 2. There it is. Don't need this one anyway. In the first one's going to go 2a. In the second one is going to go -3xy. Woo! Now I got to figure out what 4C2 is. You should know it's 6, but let's see. Menu 5, 3, 4, comma 2, 6. There it is. So 6. Now I'm going to go through and just type in all of the numbers. So it's 6, parentheses, 2 squared, parentheses, -3 squared. Oh, 216. So it's 216 a squared x squared y squared. There it is, kids. And that is binomial expansion. Those are the notes you had to take. Now, what you need to do is there are 8 other problems. There's actually 16. I will do one, and then you'll do one just like it. I'll do one, and you'll do one just like it. All right, kids, that's it. Hope you enjoyed binomial expansion.